Welcome to G Fun Facts Online, the show that uncovers the most mind-blowing and hidden stories from the world of science. Today, we're heading down under to Australia to witness one of nature's most epic and most mysterious journeys. Forget the great wildebeest migrations or the long flights of Arctic terns for a moment. I want you to picture billions, and I mean billions, of tiny, unassuming travelers taking to the night sky. We're talking about the Bogong Moth, an insect with a brain no bigger than a grain of rice that undertakes a perilous round-trip flight of over 1,000 kilometers. How do they do it? The answer is written in the stars, literally. But this ancient spectacle, a silent river of wings flowing through the Australian night, is now in danger of disappearing forever. So buckle up as we explore the incredible story of nature's navigators, the Bogong Moth's star-guided journey. The life of a Bogong Moth is a tale of two journeys, a biannual odyssey that defines its entire existence. And what's truly remarkable is that this isn't a one-way trip. The very same individuals that fly south in the spring are the ones that return north in the autumn, a feat that is incredibly rare in the insect world. It all begins in the spring, across the vast inland plains of southern Queensland and western New South Wales. As a new generation of Bogong Moths emerges into adulthood, they're born into a race against time. The tender plants their caterpillar stage or larvae feasted on are about to wither and die under the scorching Australian summer sun. The landscape will soon become barren and hostile, so driven by an ancient, genetically programmed instinct, they have to leave. Starting around early September, this great exodus begins. Billions of moths launch themselves into the night sky. They travel under the cover of darkness, flying south for weeks on end, heading towards the high peaks of the Great Dividing Range. Their destination is a very specific set of cool, dark caves and rock crevices in the Australian Alps, at elevations of over 1,800 meters. Think about that for a second. This is a place they have never been before. Their parents didn't show them the way. It's a destination passed down not through memory, but through an inherited map. A map we'll get to in a moment. Along this long flight, they're not just mindlessly fluttering along. They make strategic pit stops, feeding on the nectar of flowering eucalypts and grevilleas. This is crucial. They are building up fat reserves, fuel that they will need to survive the next phase of their life. When they finally reach their alpine destination, an incredible spectacle unfolds. The moths congregate in absolutely massive numbers. They blanket the walls of their chosen caves in a dense, shimmering, living carpet. Scientists have recorded densities reaching an astonishing 17,000 moths per single square meter. It's almost impossible to picture. Here, in the cool darkness, they enter a state of dormancy called estivation. It's essentially a summer version of hibernation. Their metabolism slows right down, and they survive solely on those fat reserves they so diligently built up on their journey south. This long summer slumber allows them to completely escape the lethal heat and lack of food in their lowland homes. Then, as summer begins to fade around February and March, the moths stir. The very same generation that arrived months earlier prepares for the second leg of their epic journey. They take to the skies once more, but this time, they fly north, perfectly retracing their path back to the plains where they were born. Once they arrive, they complete their life's purpose. They mate, and the females lay up to 2,000 eggs each in the soil. Shortly after, their remarkable life comes to an end. From those eggs, a new generation hatches, and when the following spring arrives, they too will answer that ancient call, looking to the same celestial guides that led their parents. So, how do they do it? For centuries, this was a complete mystery. How does a creature with such a tiny brain navigate with such pinpoint accuracy over 1,000 kilometers? The answer, as confirmed by recent groundbreaking research, is in the heavens. Bogong moths are one of the very few animals and the first invertebrate ever discovered to use the stars for long-distance navigation. To prove this, scientists at Lund University, led by Professor Eric Warrant, built sophisticated flight simulators for the moths. In the lab, they could project a realistic night sky. When they showed the moths a simulated starry sky, the moths consistently flew in the correct migratory direction, south in their virtual spring and north in their virtual autumn. Then came the clincher. The researchers rotated the star patterns by 180 degrees. Instantly, the moths reversed their direction of flight. But when the stars were scrambled into a random, meaningless pattern of dots, the moths became completely disoriented. This proved they weren't just flying towards a bright light. They were reading and interpreting specific celestial patterns. It's believed their primary guide is the Milky Way. That luminous band of stars that stretches across our sky is a constant, reliable feature in the southern hemisphere, making it a perfect compass. And get this, even though their eyes are tiny, scientists believe the moths can probably see the Milky Way even more distinctly than we can. The sophistication doesn't stop there. Researchers have identified specialized compass neurons in a specific region of the moth's brain. These neurons fire most strongly when the moth is heading in its correct migratory direction, relative to the orientation of the stars. It's a level of neural complexity that is simply staggering for an insect. But what happens on a cloudy night, when the stars are hidden? Well, the Bogong Moth has a backup plan. It has a sixth sense, the ability to detect and use the Earth's magnetic field. This internal magnetic compass acts as a failsafe. Experiments have shown that when you put the visual cues, the stars, in conflict with the magnetic field, the moths get confused. This tells us they use both systems together, likely using the clear view of the stars on a good night to calibrate their internal magnetic compass. This dual compass system is robust, reliable, and ensures they can complete their journey no matter the weather. Scientists even think they know how they see the magnetic field, using a light-sensitive protein in their eyes called cryptochrome. For thousands of years, this predictable migration was not just a natural wonder, but a deeply significant cultural event for the indigenous peoples of the Australian Alps, including the Gunaikurnai, Taungurung, and Ngarigo peoples. The arrival of the moths meant a time of abundance, a time for ceremony. These moths, packed with fat and protein, were a vital food source. They would be cooked in hot ashes, which singed off their wings and scales, and then eaten whole or ground into a paste to make moth meat, which is said to have a nutty flavor. These annual gatherings were huge social events, a time for different clans to meet, trade, and strengthen bonds. The mountains themselves are named in their honor, Mount Bogong and the Bogong High Plains. The word Bogong itself comes from the Duduroa word bugong, describing the moth's brown color. Beyond their cultural importance, these moths are an ecological keystone. Their annual arrival is a massive injection of nutrients into the otherwise food-scarce alpine environment. They are a feast for birds, bats, and lizards. But most critically, they are the primary food source for the critically endangered mountain pygmy possum. These tiny marsupials depend almost entirely on the fat-rich moths to survive their own winter hibernation and to successfully raise their young. The fate of the possum is directly tied to the fate of the moth. And right now, the fate of the Bogong Moth is hanging by a thread. The once abundant populations have crashed by an estimated 99.5%. In 2021, they were officially listed as an endangered species. The threats are numerous and all linked to us. Climate change is driving severe and prolonged droughts in their breeding grounds. No rain means no plants for their larvae to eat, leading to catastrophic breeding failure. Pesticides used in agriculture also take a heavy toll, killing millions in their larval stage. And then there's light pollution. The moth's migration path takes them directly over cities like Canberra. The bright artificial lights act as giant traps, disorienting the moths, pulling them off course where they die from exhaustion. The fight to save them is on. Scientists are working to understand the threats better. Citizen science projects like Moth Tracker ask the public to report sightings to help map their routes. There are calls to dim the lights in cities during migration periods. But the long-term solution requires tackling the huge issues of climate change and pesticide use. The star-guided journey of the Bogong Moth is a powerful story. It's a story of resilience, of ancient knowledge encoded in the DNA of a tiny insect. But it's also a story of extreme vulnerability, a stark reminder of how easily human activity can shatter delicate natural rhythms. The silent, fluttering river of life that flows through the Australian night is a spectacle we cannot afford to lose. Its future, and the future of the unique ecosystem that depends on it, relies on us looking up, understanding the stakes, and acting before this incredible journey reaches its final end. Thanks for tuning in to G Fun Facts Online. Join us next time for another dive into the wonders of our world.